Hello, this is Rahul. In this lecture, I am going to explain Turing machine. Turing machine recognizes the recursive enumerable language. This machine was invented by Alan Turing in 1936. This machine has input tab, you can see over here, and the input tab is divided into cells, and each cell is filled by some symbols, you can see here. Each cell has having one symbols only. Now, and if these are the symbols might be pointed by head, this is what we call read write head. With the help of head we will update the symbols, right? And we will have another things related to Turing machine, which is a machine memory, or we can say state register, that will store that will store the information related to state of Turing machine, right? These are the things. And this based on situations, and based on situations of while solving question, we will move ahead either left side or right side upon reading an input symbol from the tab, right? We'll see later. uh, Turing machine can be defined with 7 tuples. And what are these tuples actually means? We'll see. Q is what? Set of states we have. X is what? Set of symbols which are present in this input tab. So make sure that X is capital X is what? Set of symbols which are present in input tab. Delta is what? Transition. When we read any input symbols which is pointing by head, where we are going and to which from which symbol we are replacing it, everything information is given by this delta is what? Delta is function of which is taking input. X is what? Where input, where is read write head is where is moving ahead next symbol, and X is what symbol from which we are replacing this X, right? Either we'll go left, right, or hold the machine, right? Next symbol is a Q naught. Q naught is what Q naught means. This is the starting state of automata machine, right? B is a what? Blank symbol. F is what? Set of final states. As we know, it is represented by double circles. And automata, if you already have gone through DFA, then you might know the how do we design a set of final states, right? Like that. And sigma is a sigma, and these two are very different. Sigma is a set of symbols which are used to make a language. Suppose if a language is given like that, a k power n, b k power n, only two symbols we have, then we can have sigma is equal to ab. But in Turing machine, we may have more symbols. X is what? Symbols present in this input tab. What it means? Why we may replace this symbol with another symbols which are not being used in language. So we'll see later, right? So one more things related to Turing machine which is important, sometimes being asked, that time complexity. Time complexity, what a time complexity means? Number of moves of head, right? You, as we while solving questions, what we do, we move from cell to solve the questions, right? To recognize the language by replacing some things, and then we'll recognize it by halting or something. If we get blank symbols, I forgot to tell you, and all the symbols which are beyond this side or this side, all the symbols, these are blank symbols, right? uh, right? Make sure assume that those symbols are blank, which are filled. Suppose if I filled this string by myself, then all the symbols which is left or right side of this string, which are blank symbols, we always assume it in Turing machines, in of input type of Turing machine, sorry. So space complexity is number of cells of tab returns, right? About this Turing machines, if any problem which is not solved by Turing machine, what we assume that problems cannot be solved by computers. So those type of problems what we call NP-hard problems. Those who have learned advanced algorithms or NP reductions, those can understand very easily, right? We'll see first questions related to Turing machine. First one is we have a language given. This is a question. We have to design the Turing machine for this language. Language is a power n, b power n, where n is greater than or equal to 1. For this, we have to build up some rules, right? We have this input tab, as we know. Let's take n is equal to, first we take n is equal to 6. Then we may have a string a power 6, b power 6, right? I hope this is clear. Now we'll start from read write head. This is a read write head. We start from here, right? What we'll do, sorry, if we get first a replaced with y, x, right? I have written over here, this is replaced by here, right? Using it has replaced here. Now I will move toward right side. I will go this side. If a is in encounter, then I will do anything. I replaced with same symbol. And once I get b, any b, first b, I will replace with new symbol which is y. Now I will move from there backward, and I will stop when I get any x, and I continue move when I get any b, right? I will stop where? When I get x, because this was replaced by x. So that is the reason I will stop here. Then I see very next of x is a. What it means, I will replace it by x. Then I will move right side. Right side, what do I see? I will make rule. Either I get a or I get y. This y was replaced by this one. Either I get y or a, I will move right side. And once I get first b, I will replace with y. Now I will make rules like that. When I get y or a, what I do, I will simply replace with same symbol. I don't do anything. And once I get any x, I will stop there and move toward right side, very next right of x, which is a. If it is x, I replace it by x. Right? Again move toward right side. You can see over here. Until where when I get first a y, first b, I will replace by x. For then I repeat same things from here. I will once first x encounter, then very next to the x I will see if it is a. Then what I do, simply replace with the, for this replacement I will replace a 1 y here. Then again I come back toward this side and replace this x. For this replacement I will replace 1 b. For this replacement I replace with. This is the process I repeats. And what I see in the last step, what is happening, suppose once you replace this y, this b with y, what do? You come back, and what do you see? This x which encounter, and right after this x you see there is no a. What it means, if you get all the y, what do is you go right side, and until where you go, until you get any blank symbol. If you get blank symbol, what it means, all the b's are replaced with a, right? Because we were replacing each b, for one b, for one a, one b. That is the reason, if all b's were replaced by y, then only we will get blank symbol. So we'll develop a machine. So you can see over here. So we'll start from q0, and what we see, I replace first A with y, sorry, yx, and move right side. Then either y is coming or a is coming. I simply don't do anything. So replace with same symbols and move toward right side, as we have done. Either a or y encountered. I am searching for b. Once b occurred, first b occurred, I will replace y and move toward left side. Now, while moving left side, I when A or Y occurred, what we do? I don't do anything. Simply move toward left. Once X occurred, what we do? I don't do anything and move very next to the X of what we found. If I found A, I don't do anything. I replace. Sorry, I replace with X and I move toward the right side and with for this one replacement I will replace with this one. Then I don't do anything, so I come back to same place. Once all the replacement is being done by this loop, then very next to x will get y. As I told you, very next to get this y. So if this happened, what it means, in the last, while moving toward all the y's, we get blank symbols. Now they will reach at final state. This is what our aim was, whether this language is belongs, this language string a power 6 b power 6 is belonging to this language or not. So thank you for watching this video.